So today we're starting a new unit 4, and so we're going to look at complex numbers, which involves how to take the square root of a negative number. So pretty much we're going to start with the following, this right here. So the definition of an imaginary number is that the square root of -1 is going to be represented by I. So if you recall, before, we couldn't take the square root of -49, for instance, because no number times itself gives you 49, or -49. So we said that that was not a real solution and that we would deal with it later. Well, later has now come. So somebody had decided that they were going to figure out how to take the square root of a negative number. So they let the square root of -1 equal the letter I, and it became the set of imaginary numbers. So all numbers, including real and imaginary, is part of the set of complex numbers. And the set of complex numbers is split into real, which you should be very familiar with, and imaginary. Real numbers are split into rational and irrational. So rational numbers are numbers that can be expressed as a fraction. Irrational numbers cannot be expressed as a fraction. Some examples of irrational numbers would be pi, the square root of 2, the square root of 18, the cube root of 4, any non-perfect root, or any decimal that does not end or repeat. So basically over here in rational numbers, any decimal that ends or repeats can be expressed as a fraction. And of course, with rational numbers, we have the set of integers, the set of whole numbers, and the set of natural numbers, which is your set of counting numbers. So then all of these make up the set of complex numbers. So a complex number looks like this. So it has a real part. So the real part is your A, and it has an imaginary part, which is this B times I. So anything that has an I attached to it is the imaginary part of the number, and anything that is just an integer or a rational number is, well, I guess it could be irrational as well, so I digress, but that's part of the real part of that complex number. So before we get into this, and oh, by the way, one more thing. This is called standard form. So standard form just means that you have the real part of the complex number first, and then you're going to add or subtract the imaginary part of that complex number. So let's get more into what is an imaginary number. So we already talked about the fact that I is equal to the square root of -1. But we don't ever write the square root of -1. We always replace it with I. Why? Well, I is a whole lot simpler to deal with than the square root of -1. It's shorter. Plus, because I looks like a variable, we can add, subtract, multiply, and divide things with an I in it, just like you would if it were an X or a Y or a B or a W. And we'll get more into that as well. There are only 4 possible imaginary numbers values that you can have. So one of them is I. Then if we had I squared, well, I squared is no different. Whoops, that would be the wrong one. Try this again. I squared would be no different than I times I. Well, if I is the square root of -1, then we would have the square root of -1 times the square root of -1. And we have learned that a radical times itself gives you the number underneath the radical. So that means that I squared must be equal to -1. So anytime we have I squared, we will replace it with a value of -1. So then I cubed you could read as I times I times I, which is the square root of -1 times the square root of -1 times the square root of -1. But I really don't like writing it this way. That's a lot to have to stretch out. We already know that I squared is equal to negative 1. So I could replace this right here with I squared, and so let's do that. So I'd rather you look at it in the following. I'd rather break it down into something that has a value of negative 1 than something that doesn't. So another way that I could write I cubed would be I squared times I. Well, we just figured out that I squared has a value of negative 1, and then I we're going to leave as I, because we don't write anything for I. We're not going to replace it with a negative 1. So that means that negative 1 times I has a value of negative I, because we're not going to write the square root of negative 1. So we can write things in terms of I to the first, but nothing higher than I to the first. So this is our value for I cubed. Let me write back over that so we can see it. There we go. Okay, so then I to the fourth, kind of in the same vein, I to the fourth, I can rewrite as I squared times I squared. So why write it as I times I times I times I when I to the fourth is I squared times I squared? And we just determined that I squared earlier was negative 1. So that would be negative 1 times negative 1, which gives you a positive 1. So we can replace I to the fourth with a value of 1. So essentially, you're only going to have these 4 values for any of your i's. I mean, we can go all the way up to I to the 1,049th. It's going to be one of these 4 values. So it's either going to be I, negative 1, negative I, or 1. So again, I is equal to the square root of negative 1. I squared is I times I, which is the square root of negative 1 times the square root of negative 1. Radical times itself gives you the number under the radical. We've split I cubed into I times I squared, right? So I squared is negative 1 from here times an I gives us negative I. I to the fourth is I squared times I squared. Well, if I squared is negative 1, negative 1 times negative 1 is 1. So what if I had I to the fifth? So let me add that here. So I to the fifth. So you should start to see a pattern forming here. So my favorite is I to the fourth, because I to the fourth has a value of 1. So if I can break anything that's over I to the fourth into the I to the fourth groups of I to the fourth, and I've got just 1 times everything, and 1's very easy to multiply out. So I to the fifth can be broken into I to the fourth times an I. That gives you 5 i's. Well, I to the fourth is positive 1 times an I gives you I. Look at I to the sixth. Well, I to the sixth can be broken into I to the fourth times I squared. Well, we know that I to the fourth is 1 and I squared is negative 1. So we get negative 1. I to the seventh is equal to, I can split that into I to the fourth times I to the third. 4 and 3 is 7, right? And so then I to the fourth has a value of 1, and we just proved that I to the third has a value of negative I. Well, 1 times negative I is negative I. Finally, I to the eighth. I to the eighth can be broken into I to the fourth times I to the fourth. Well, I to the fourth is 1, so 1 times 1 is 1. And as you can see, this pattern of I, negative 1, negative I, 1 has started over again. I, negative 1, negative I, 1. And it's going to continue to do that no matter what I choose. It's going to go into those multiples of 4. So these are the only 4 values of powers of I that you can have. So what do I do if I have something like I to the 70th? What am I going to do? Well, if I can figure out how many groups of I to the fourth I have in I to the 70th, all those groups of I to the fourth is going to be 1. So if I could figure out how many times 4 divides into 70, because think about it this way. If I had divided 5 by 4, then 4 goes into 5 one time with one remainder. That one remainder is the number of i's I have out here, so I have I to the first. Well, if I divide 6 by 4, 4 goes in there once with 2 remaining, and I have I squared. That's my 2 remaining. Well, I squared is a value of -1. Notice that my answer was -1. If I divide 7 by 4, 4 goes in there one whole time with 3 left over. So I would have I cubed left over, which was -I, -I. If I divide 8 by 4, well, 8 goes in there evenly, or 4 goes in there evenly twice, so I have no remainders. If I have no remainders, then it's I to the 4th, which has a value of 1. So if I have 1 remaining I, it's going to be just I. If I have 2 remaining i's, it's going to be -1. If I have 3 remaining i's, it's going to be -I. And if I have no remaining i's, because 4 went in there evenly, then it must be a multiple of I to the 4th, which means I'm just multiplying 1 times itself however many times. So that's why we use 4 and divide that out. So if I divide 70 by 4, some of you are having trouble with that long division. I'm going to take 70 and divide it by 4, because I only care about the remainders. So 4 goes into 7 once, leaves me 3, bring down the 0. 4 goes into 30 7 times. 4 times 7 is 28. And that leaves me with a remainder of 2. Since I have a remainder of 2, that means I'm going to have an I squared, and I squared has a value of -1. So that's all you're going to do. You're going to take the exponent and divide it by 4. So you try these next 5 problems. So here they are. I want you to pause the video, and I want you to divide each of those exponents by 4, and then figure out, based upon your remainder, what the value of I is going to be. So pause the video. Okay, so here's what we're going to do. We're going to divide 27 by 4. And so my long division is going to be 27 divided by 4. 4 goes into 27. 4 times 6 is 24. So that's going to leave me a remainder of 3. So since I have a remainder of 3, that's I cubed, and I cubed has a value of -I. All right, so 23. I divide 23 by 4. 4 times 5 is 20. That leaves me with a remainder of 3. So again, that means I have I cubed, which again is -I. So I cubed, I to the 27th, I to the 23rd, all have values of -I. Let's divide 21 by 4. So 21 divided by 4. 4 goes in there 5 times. 4 times 5 is 20. That leaves me with a remainder of 1. So since I have a remainder of 1, I'm only going to have I to the 1st, and we leave I to the 1st. Divide 18 by 4. 4 goes in there 4 times. 4 times 4 is 16. That leaves me with a remainder of 2, which means I would have I squared, and I squared has a value of -1. Finally, we're going to divide 17 by 4. 4 goes in there 4 times, which is 16. That leaves you with a remainder of 1, which is I. All right, let's bump it up. So now that we know how to simplify powers of I, let's actually take the square root of a negative number. So when you have the square root of negative 49, we can split that negative 49 into negative 1 times 49. Then you can break apart this into the square root of negative 1 times the square root of 49. Well, we know that the square root of negative 1 has a value of I, and the square root of 49 is 7. But we cannot write I7 because I looks like a variable and it has all the properties of a variable, and so we always have to write the number in front of the variable. So the answer is 7i. So now for the square root of negative 5, again, you're going to split that into negative 1 times 5. Then this splits into negative 1 times the square root of 5. The square root of negative 1 is I. You can't take the square root of 5. And so in this case, if our coefficient is actually a radical, you will put I in front of the radical, because look what happens if I don't. If I wrote it square root of 5i, it's very difficult to tell, is that I underneath the radical or is it outside of the radical? So because it makes it difficult to tell, and we do the same thing with variables, we wouldn't write, if we had x squared underneath the radical, we don't put the x here when we take the square root of x squared, we put it out in front. So the same thing's going to happen with I. So this is our solution here. So then pause the video and I want you to figure out what the square root of negative 32 is. Okay, so we could break this apart into negative 1 and then 5 2's. Then I'm going to take out a group of 2's and a group of 2's out in front. That leaves the 3 left over underneath. And then this negative 1 is going to come out as an I. And so then we have square root of 3. So 2 times 2 times I is 4i square root of 3. Now we're going to do some other operations. So let's just do some simple multiplication and power to power. So all of the laws of exponents apply to things with I in it as well. So here I am squaring both the 2 and the I. So the 2 has to be raised to the second power and the I raised to the second power. So 2 squared is 4. When I square the I get I squared. But we know that I squared has a different value. The I squared is equal to negative 1. So really 4i squared is equal to negative 4. Remember, we can't leave I squared, I cubed, or I to the fourth in a problem because they have values that we just went over. So then in the next example, we're going to multiply negative 3 to 5 and I to I. So negative 3 times 5 is negative 15. I times I is I squared. Again, that I squared has a value of negative 1, which changes our answer to just 15. So whenever you have I squared, like right here, you could say, oh, the I squared, it just changes the 4 to its opposite sign and the I squared goes away because I squared has a value of negative 1. So you could go from here to this answer. You could go from here saying that I squared is negative 1, so it changes this sign to a positive. So notice that we went from a positive to negative, negative to a positive, and when we did that, the I squared went away. So what happens when we multiply, or when we add and subtract? So let's look here. Here there's nothing in front of these parentheses but a 1, so if I distribute a 1, I get 3 plus 4i. Same thing here. If I distribute a 1 in here, I get 7 minus 6i. So the purpose of the parentheses, really there is none. So I'm going to drop the parentheses and line up like terms. So the 7 lines up with the 3, the negative 6i lines up with the 4i, and then I'm just collecting like terms. When you collect like terms, the variable string does not change. So 3 plus 7 is 10. 4 and a negative 6 is a negative 2i. And then this is our answer. And in addition to that, this answer is in standard form. your answer should always be in standard form. But if you see, put your answer in standard form. This is what they're looking for. Note that this is the real part and this is the imaginary part. The real part always has to come in front of the imaginary part. So that on this example with subtraction, we do have to distribute this negative into here. I can drop these parentheses because there's a 1 in front. So I'm going to write 8 minus 2i, but then I'm distributing a negative 1 into these parentheses. So when I do so, a negative 1 times 7 is a negative 7, and a negative 1 times 3i is a negative 3i. And so now when I add 8 minus 7 is 1, negative 2 and a negative 3 is a negative 5i. And that also is in standard form. So this is also in standard form because we have the real part and the imaginary part. Now let's look at multiplying a monomial to a binomial and a binomial times a binomial. So it's no different, again, than operations with an x. So if I were doing x times 3 plus 2x, it'd be the same thing. So exponent rules still apply. So I times 3 is 3i. And then I times 2i is 2i squared. And of course we can't have anything other than an I, so that 2i squared gets replaced. So we have 3i. And remember, I squared has a value of negative 1. So we really have 3i minus 2, and because we want this written in standard form, the negative belongs to the 2, so the negative 2 needs to come first. So we end up with negative 2 plus a 3i, properly written in standard form. Now you could do a shortcut. Instead of this step, you could start to realize that, oh, this I squared is going to change the sign of the 2, and you can go directly from here to just a negative 2. Now let's try this one. If I have a binomial times a binomial, I'm going to get 4 terms. So 3 times 7 is 21. 3 times a negative 2i is negative 6i. Negative 5i times 7 is negative 35i. Negative times a negative is a positive. 5 times 2 is 10. I times I is I squared. And then we are going to collect like terms, so we get 21 minus 41i plus, and instead, actually it won't be a plus. Let's look at this value right here is going to change into a negative 10. Why? Because the I squared is negative 1 times 10 is negative 10. So then we've got a minus 10 here. Then 21 minus the 10 is 11 minus the 41i. And that is in proper standard form. Finally, we have division. Now, I'm going to start not with the problem you see here, but I'm going to start with something more simple. So, for instance, what if I had 3? Oh, let's go. Let's see. 3. Remember if we had 3 radical 3 over the square root of 5. So if I did something like this, in order to rationalize it, we'd have to multiply it by rad 5, rad 5. Well, in this case, and that was just because we couldn't have a radical in the denominator, so what if I had instead an I in the denominator, and I had 3, oops, I don't want that color. What if I had 3 over I? We'll just make it pretty simple. Well, I want to make this I into either I squared, which would be a value of negative 1, or I to the 4th, which is a value of 1. I tend to try to make this into the closer value, whether it's closer to I squared or I to the 4th. Since I is closer to the I squared, I'm going to turn it into I squared. All I need to multiply it by to make it into I squared is another I. Because remember, I is the square root of 1, so I can't have it in the denominator. What I do to the bottom, I have to do to the top. So I end up with 3i in the numerator, and then I squared in the denominator, but I squared has a value of -1. And we can actually divide that into 3i, and it makes it -3i. We no longer have an I in the denominator, which means we don't have a radical in the denominator. So what are we going to do up top? So up top, when we have a plus and a minus, remember we have to multiply by the conjugate. So the conjugate of 3 plus 4i is 3 minus 4i. What I do to the bottom, I need to do to the top. Okay, so then I'm going to have 4 terms, because I got a binomial times a binomial right here. So I'm going to have 4 terms up top and 4 terms on the bottom. So let's go ahead and go through that multiplication. So for the first one, 2 times 3 is 6. And then 2 times -4i is -8i. Then we've got -i times 3 is -3i. And then -i times -4i, negative times a negative is positive. 4i times I is I squared. Then that's going to be over. Then we're going to distribute. Let's see, we're going to distribute. I'm going to get a custom color. Hang on. Aha! I'm going to get a beautiful pink. Perfect. So I got 3 times 3 is 9. And then 3 times -4i is -12i. Then I'm going to distribute the 4i to the 3. That gives me a positive 12i, and so those 12i's should cancel, which is our whole point, because we want to get rid of the I in that denominator. And then 4i times -4i, positive times a negative is a negative. 4 times 4 is 16. I times I is I squared. Then this gives us, we'll move this over, so we get equals. So remember the 4i squared, this I squared is a -1 times the 4 makes it a -4. So I'm going to turn this into a -4 so that when I do 6 minus 4, you understand where I got the 2 from. Then I have like terms here, so -8i and -3i add to give me -11i. Then the 12 and -12i are going to cancel. This -16i squared, the I squared is a -1 times a -16 changes this into a positive 16. So I really have 9 plus 16, which is 25. So normally we would be done, but we have to put this into standard form. Standard form means I need to split the real part from the imaginary part. So because both of these are being divided by 25, they are each divisible by 25, so I have to split that out. So it's equal to 2 over 25. If I could reduce that, I would, but I can't. And then the sign here will always go here. So then because the I is negative, so we got a negative, 11 over 25, and you have to take the I out of the fraction and hang it out there to the side. Strange but true, this is in proper form. All right, so go try your homework. Ask me questions.